here. Says it. Looks like we got it going. It's good. Wednesday afternoon. Gonna get back getting into our Solidworks today. Our Delta Picker. It's a good day to hang out and Solidworks and chill. By the way, the music is from YouTube's library of free stuff. It's gonna be funky dance and electronic today. So this is your first time to the stream. I don't know, we're trying out new stuff, but appreciate it that you're showing up for the first time if you're watching this on demand. Yeah, if you haven't caught part one of this, we started making a 3D Delta Picker. So normally this channel it's a little loud in my ears. Normally this channel is all about automation and automation using Siemens technology, and we come at it from the electronic side of it, but you kind of will find out the more and more you're doing automation that, hey, you probably need to kind of at least think about the mechanical design. You can never kind of automate your way out of a bad mechanical design. If you're using something that's bad, then it's always going to be bad no matter how well you program the PLC or the drive or whatever. And so that's kind of why we're doing this, trying out some new stuff. I'm still going to be doing all the automation streams and the Siemens PLC talk and all of that stuff. It's just kind of these more relaxed things. Eventually we're going to be talking about how to control this Delta Picker that we are putting together. We're going to control it with a Siemens 1500 processor with the built-in technology objects, the kinematics technology objects. So yeah, that's why we're doing this. Again, it's more laid back for this. Honestly, I'm not a SolidWorks expert, so there are a lot of things that you'll see me doing. You might be like screaming at the stream and just being like, hey, there's a much better way of doing things. But yeah, if you know of a better way of doing something that you see on here, be free to drop it in chat if you're live, or if you are watching it on demand, feel free to drop a comment on it. Again, this is just kind of like laid back sort of session. Try to get started, get everything opened up from where we were yesterday. I'll kind of show you where we dropped off yesterday. Actually, I don't even know if, as you could hear, if you know that you're familiar with SolidWorks, you know that means there's some things that are wrong. So I just opened up the assembly, and I know I told everyone yesterday that I wasn't going to mess with anything off stream. I lied. Sorry. It was driving me crazy, kind of like we were doing this rotation with some of the components, and for some reason 2 out of the 3 components, it just didn't work. Or sorry, 2 out of the 3 were fine, but then 1 did not work, and so I was trying to kind of figure out a way to kind of get that working, and it just, yeah, took a little bit of work to get going. So the way that I ended up doing this, so I'm gonna flip over and let's see, what do I want? I want to be down here? No, I want to be down here. Yeah, there we go. See? Because as I look up, there it is. Isn't it beautiful? It kind of looks similar to what we had yesterday, but it's vastly different in its concept. Because what we did yesterday was essentially had a big base plate that was just a big square, and it's in the front plane, so I can go normal to that. Again, if you're new to using SolidWorks or whatever, you'll see me kind of just like, I'm going to be using some basic features. There's a ton in SolidWorks that I may not use, but I'm just kind of like doing kind of a basic process and how to think of how to do and design. And yesterday I made this arm center lines. And if you're not familiar with the way that a Delta picker is designed, essentially you have 3 sets of 2-position arms at 120 degrees and motors on each of those arms, and there's not a lot of inertia out in the what's it called, like on the actual actuator itself. So like the end effector does not have a lot of like inertia to it, so you can move really fast and have really tight control. And one of the cool things about these Delta pickers is that you have your motor, which this is what we're designing around, is this 1FL6 servo motor. You really never will go over 180 degrees on this shaft. And so obviously this is a 2 or 3,000 RPM servo motor, and so you can get some incredible accelerations with this. And so the entire range of motion for this is over only 180 degrees on your axis here. Now, if you don't have a good encoder, then that could be a bad thing, because you can have some pretty significant movements just with very small movements of your motors. But one of the cool things about this is all 3 motors are in the same plane. They are just knocked off to the side, or sorry, kind of their axes of motion are just 120 degrees out of phase. So we also made this other part. I guess I can open it up as well. The arm. We made one of these, and we 3D printed it yesterday. Well, you didn't, I did. But we went through the whole process of kind of setting this up, and this was just kind of to give me a mental kind of like base of where things are, like how big things are, because I have the motor, but then I didn't have anything that I was kind of designing off of, because you could see from this assembly that we have here, maybe not, yeah, here's the assembly. It's definitely Borkin, but it doesn't like all these mates, but you can kind of see how this is going to look. And I don't know, I've got to mess with the presentation. I need to put the like reflection, I didn't put it in the right plane apparently, because my reflection is wacky. Anyway, you can see how this Delta picker is going to look. And I want the scene off. Apply scene, none. Can I just like, I just want a plain white scene. Anyway, we'll deal with that later. But I went ahead and printed one of these out just to kind of give me an idea of how big things are. And I just kind of threw some stuff together, 150 millimeter length on this arm. Just kind of an arbitrary shaft here. This is not going to be able to be used for anything because I didn't think about it at the time, but I could have at least made this hole to where it would go over this shaft, but I didn't, because this whole point was to really just kind of get us a base of reality for how big this thing is. Obviously, I have the advantage of being able to 3D print stuff, whereas you may not. A lot of times people will use this, we use cardboard, so cardboard mock-ups, things like that. But yeah, so be sure if you're coming in on stream and to drop a like on the stream, get it out there to anybody that's out there. And yeah, also if you're new to the stream, be sure to drop in chat where you're from, and welcome you in. But yeah, we're just gonna continue along this kind of design process with what we're doing here. So we're gonna go back to our arm, not our arm. we're going to go back to our base plate, this guy. And I want to show you how I did this, because I'm going to roll back real quick the circular pattern. And I realized, I'm like, okay, the way that we really need to do this is by making this a body and then just rotating this body. And one of the chatters on here, measure twice, cut once. I kind of know him in real life, and we were kind of talking about some of the other things, and he posted in the Discord one of kind of like a little mount that he made. He downloaded a 3D model of the 1FL6 motor, and he just kind of went through and it made me kind of start thinking about, oh, hey, let's just make a mount for this motor and make that base plate to where when we do that rotation, it forms the solid base plate, and it also forms the mount. And then that way I can print this one single mount out. I can test all of my tolerances, test all of this stuff for my motor, just make sure everything's going to work pretty well. I'm also on this, I'm probably going to import in, see if I can find that Solidworks file. I'll probably do a CAX download. I'll probably show y'all how to do that as well, to get the 3D models for this stuff. But yeah, so as you can see, instead of having the full base plate, I started kind of playing around with making it a making it off, you know. And so one of the things that we're kind of gonna eventually do is try to make sure that this base plate lines up perfectly, because when we roll forward this, there's some interference with the way I have it drawn right now. And when we go to and do the STL file, the way it goes through to kind of like to make this work, like and slice it up in the 3D printer, this method doesn't quite work because of these overlapping, it doesn't know what to do with those triangles. So we're going to clean that up at some point. I don't know if we're going to clean it up now, but you can kind of see how, if we were to continue with this design, how it would need to be changed. So we kind of go through here and just maybe try to polish this up a little bit. So it looks like we definitely need to have, first thing I want to do is clean up this edge. So and I can kind of see we're going to need to have it step out like this on this other drawing here. But let's see if we can just kind of go from there. So yeah, again, we're just laid back, chilling, working on this design. If you're watching this on demand, be sure to skip forward, see through progress. Again, this is just kind of give it an option if you're coming in and wanting to, on these streams, wanting to kind of hang out and work with stuff. That's what we're here for. If you come in on stream like this and I'm just kind of hanging out, feel free to ask other questions too. This is kind of your opportunity just to ask any sort of automation questions. But let's see. Let's work on this base plate design, because I feel like that is going to be the crux of this. So we really need to kind of make a point here, don't we? So maybe can we modify the arm center lines and it keep everything there? No, we can't. But what I think we need to do, all right, let's clear this back. Let's think through. So we could make this and then rotate it, and then that center line thing would be here, because we know how far this from here to here is. Oh, I do want to do that. So I was thinking about it. Let's change one thing first. On these extrusions, let's modify this sketch. And instead of having 10 millimeters and 7.5 millimeters here, I want this to be both 7.5. Because I realized after after kind of Measure showed me what he had come up with, I realized that most of the strength of this plate is not going to be on the thickness. It's actually going to be in the structure that we haven't built yet. We're going to build some triangulation on this backside in order to kind of support that motor, and we just haven't done that yet. So I want to make these 7.5 millimeters thickness, and then so we can see this overall thickness from here to here. We could measure that, or we could just kind of, I don't know if I want to leave it driven, but it's 22.5. So yeah, I want to cancel that. I just wanted to see that. You can also always use the evaluate measure and then kind of go from here if you can't add, and then just look at the delta x 22.5. So want to do that, save that change. We're just changing that. We still want that to be 30 millimeters in between there. And so now we can go, and we know that we want this kind of construction line to go out on this arm center lines. We want to draw a line. We'll just do this like that. We're going to make it for construction. Make that for construction. And then we're going to make this between here and here. We're just going to drive that for 22.5. And that might be annoying on having that shown right there. I'll show you why I say that. Because when we actually build this, it'll show that dimension in there, and it would be kind of sticking out on our drawing the whole time. But we can always hide, or we can always hide that arm center line. But yeah. So we're just going through here and kind of looking at this. So what I want to do now is we have this rotation. So actually what I want to do is I want to select these two lines and I want to delete them. And I'll say yeah. And that's probably going to break a lot of stuff. Well, and then we're going to select everything here. And then we're going to do, actually I don't want the arc. So unselect that. Then we're going to do this guy here. I want 3 equally spaced over 360 degrees. And that will work. Yeah. So now we actually have this kind of shape that we're looking for. We're just trying to build up our shape. It's probably because it's overlapping. Oh, yeah. That's fine. Because it's dimensioned off of other things. What is this? Dimensions of reference no longer exists. Oh, yeah, of course. Right. We know that. We'll redo that here in a second. Because we're about to redefine this drawing anyway. So this like arm center lines, if you're just watching this, you didn't watch yesterday's, all it's doing is kind of giving us a reference for everything that we're doing. You can see that these lines are lining up with kind of what we have going on here. And so now we can see, now we have this shape that is in this arm center line. thing. And so now we can go through and honestly, we're going to delete. We're going to delete this. Delete this. That looks good. We're going to go here. Here. There. There we go. Looks a little better. And then now that should not interfere. Now, we have these lines here, but that should be a 0 dimension. So what I'm going to do is I'm going to test in our slicer program just to make sure that what we have going on here, is good. So what I'm going to do is I'm going to save as new, and I'm going to change this to an STL and base plate, and I'm just going to overwrite that. And it looks like that's a lot better. Now I'm going to go into my studio here. And I'm going to go prepare. I'm going to open up that base plate. And it already looks a little better, and I'm going to slice it. And make sure that it's going to slice properly. Yes. That is how we want it to be. So yesterday, because of those overlapping geometries, it was actually creating this kind of like gap. And again, if you're watching this and you're not familiar with like the 3D printing type, this green stuff here is what's called it's not lattice. Scaffolding. It's scaffolding. So remember, 3D printer prints a layer at a time. So as it goes through, if there's any gaps, it has to support what is kind of hanging here. Because as the 3D printer gets up to this kind of level, there's nothing for that to like stay on. So it'll just drop. And so you can't get these circles. So if we kind of like zoom in on these, you could see all the different layers, and these little structures are built so that yeah, it supports these kind of steps. But anyway, so that geometry that we just made will actually 3D print. It'll actually print. So now we can kind of go back and I'll show you why we did it that way, because now we can always just go like this right here, and we can make changes to this body, and whatever we do here will then, when we roll that forward, will get duplicated. And so like in the build process, because what we're about to start doing is kind of adding in some of the features for this plate here, and I'm actually going to 3D print this, not the whole thing. And so I want to see if we can go through and find, or do the download. I'll show you how to do the download for the 3D model for this. Yeah, again, if you're watching this on later on demand, be sure to, and you find anything helpful, but you have questions, be sure to drop a comment, even if you don't have to join in live. I know this is kind of like an odd time for most of the people that are watching. I mean, it's like 5:30 in Eastern time, so I understand that it's definitely not a time that most people would be watching, but I wanted to just do a little bit of a stream today, and yeah, kind of go from here. So I'll show you bring this over here. And yeah, so this is the Siemens support website, right? And so what I want to do is I have a part number over here for this. Let's see, let's do it this way. So I want the 3D model for this guy. So it's a 1FL 6042 -2A F21 1MA F21 -1 MA1. So again, this is a Siemens support website, and so we should get a product link here. You go to this product link, and there should be product details. And CAX is not here. So maybe we have to do it from CAX itself. So let's take this right here and go Control C. And we're going to go to CAX downloads. And we're going to click New. These are some stuff that we had before. And we're going to say add product numbers. Bring that in here. Hopefully it'll bring up the fact that, okay, we've got this. We're going to say continue. We want the 3D model, and if you notice, it's a step file, which that just means we'll be able to bring it into our file or our assembly as a step file. So, and we're going to create this CAX download. 1FL, or we'll do Delta Picker Motor model. So now when we go to our CAX manager, so we go to this download manager, we see that we have this Delta Picker model that is in progress. You can see I have some other stuff that I have previously downloaded, some schematics, layout drawings, tech data, like data sheets, things like that. So we're gonna just sit and wait, and this gets refreshed every now and then. So we'll start that, and we'll come over here, and we'll get started on kind of some other stuff. So the first thing that we know is that we're wanting to kind of connect this guy to this motor, right? So how are we going to connect that? And it's been a couple of different ways that I was thinking about doing this, because if I actually wanted to 3D print this, I have been kind of considering the fact that, like, this little hole, if I strip this out and make kind of a keyed coupling and just like make a key for it and then key this onto it, I could definitely do that. But then if I strip it out, I have to completely reprint this whole part. And I don't think I want to have to do that. And so I want to actually design a kind of a two-piece coupling here that one slips over this kind of the output shaft, and it has the key on it, and it is a fairly small component. And then you have a much stronger component on this outside, so that this component that interface will not break. So I was thinking kind of like a splined shaft in here. So like a splined to a, what's it called? Conversion. So like a keyed. So a keyed shaft to spline shaft converter. And then I could slip that converter onto here and then slide this over the spline shaft and it have a lot stronger connection here. And if something's going to break, most likely it's going to be this little bitty keyed shaft here. And I can make the tolerances on this really, really tight so I can drive it on almost like a compression fitting. And so that's kind of what I'm wanting to do with this. And so let's design that kind of like key shaft concept, and then we can kind of go from there. So it's actually, we're gonna have to make a new part, and we'll call it like a coupling or something. So let's just go ahead and do a save to this PC. Again, I'm using because I have contractors and people that do this mechanical design for me for Alpha. I just have the maker's version of this because none of the parts that I design on this version do I actually sell. But what I will do is I may try a prototype or whatever, and then the final design or whatever, I will get my mechanical designers that have the full feature, like professional versions and everything to design. This version that I'm using, you can get for about $10 a month, or I think it's about $100 a year if you pay up front, and it's the full featured versions of it. The only stipulation is you're not supposed to make, I think it's like $2,000 or something off the parts you make on it. So you could still make a little bit of money off of it, but if you were to ever do a business or whatever, you would want to have a full version. So spline, and this is a 30 millimeter shaft, I think. No, 20. Really like 19. Anyway. 19. Okay. So, kind of get the idea going here. Okay. So we're gonna want to not do what I just did. I want to do this in the top. Come on. This music is definitely something, isn't it? Yeah. So let's get this propped up. And what we're going to do is we're going to make a drawing, sketch. We're going to do circle. Now we'll just make, and I always forget to do this because I keep forgetting to set that. So I'm just setting my units. And let's see what this is. I don't think it's going to need to be that big, but we'll say 15. Just ballparking it right now. Does that make sense? No, because I'm going to want some kind of like geared spline looking things, right? So let's, because that's only 30. We have a 19 millimeters. Let's say this is going to be, let's just say 25. So this is, because we're going to have, what we're going to do is we're going to have two cuts. We're going to have a cut for our keyed shaft side, and then we're going to have the spline cut. So we're going to do two different cuts. And I mean, honestly, we probably, yeah, we'll do a couple different ways, but let's do our keyed shaft. Honestly, we could just do this in one extrusion, just to make it simpler. And that's fine there. Oh, no, that's not what I meant to do. so I'm gonna make this for construction because it's eventually not gonna be there. And then we're gonna do this, which is gonna be 19, so what's half of 19? And I think that, this is a part that I'm definitely going to 3D print tonight, just because I want to test this interference fitting. Like, I want it to actually see how tight it is. And 9.5, normally with tolerances of 3D printing, you would have to go a little bit under that, otherwise it wouldn't actually fit together. So that's what we're testing on this stuff. Okay, so that looks good there. Except it doesn't. I'm probably just gonna do it as a cut, and then do like a cut, like a revolve feature around it. That's probably gonna be the best way to do that. And because what you could do is do one drawing and then just do an extrusion and all in like at one time, but then you're having to juggle kind of like closed circles and things inside of here, and it makes it a little bit more difficult right now. But let's just kind of do this. Because see, it doesn't know what's in and what's out, and so now what we want to do is we want to do just kind of a key to insert. So we want to get a for construction. Okay. Because I want to set a key out from there. And again, I'm like measuring this stuff just to kind of like get an idea of like actual measurements for this. I think this is a 6mm key. Yep. So we want to do this. And then we're going to set this. Thank you, Lenovo. That's exactly what I wanted. And then from here to here, also be 3. And then I guess that's defined off that center line. How deep do we want this? Again, we have the 3D model that we could use, but it looks like 3.2 depth. Yeah, 3.1. So we're gonna say that this is three. And this is probably gonna jack everything up, but now we want this and this to be equal, just in case. Now, here's where the fun part happens, because we have this key here on the inside of this circle, but this circle, it doesn't know where the closed area is to do an extrusion. So we actually have to delete this circle and make an arc. We want a 3-point arc. Is it a 3-part? No. That. So I might be able to do it with this. Looks like it. that should. So now if we measure, why is the radius 23? I mean, we want that radius to be 19.5. Did that work? Let's see. I think that is fine. Yeah, because those are all set. Yeah, that works. Okay. So now we have this feature. That is not correct. That's probably why it jacked it up. So no. All right. Where is? I don't know how that messed up, but and it's like yeah. Anyway, there's always fun things when you're working through these type things, and especially when like you're kind of like used to doing something some way. But we definitely want to make sure that these are like this. We want these 2 points to be coincident. Should be able to. Nope. Should be like select next, select other. Arc, point, line, spline, spline. Anyway. I don't know, I just don't think that's gonna work. Because that circle is, I mean, that's probably okay. It's a little tight though. I wonder what's driving that's making it ever so slightly different. Anyway, I think it's close enough. Yeah, I can't change it because now that those are defined, those are equal. That. All right, that should be okay. Yeah, so that looks like our shaft, right? Yeah. So now, is that gonna work? Making sure that just in my mind that like that is actually gonna work. This is pretty tight tolerance on 19. I don't think that's gonna be tight. That's gonna be too tight. I know that it's like, oh, it's only you say it's only like a few hundredths or a couple of hundredths off, but That's quite a bit. So that's going to be like, I don't know. Maybe I could just, yeah, I'm going to leave it and see. I'll print out like a real quick version of this actually. How about let's just do that? That's a good idea. Let's just do that. Let's just print out a quick version of this just to make sure that this isn't going to be totally off. We'll just make kind of like a washer. And so we'll do feature, extruded boss base, sure, 10 millimeters. And then we're going to save as new. And then we're going to call that an STL file. Save that. Yep. All bodies. Go here. Delete this. Delete. Oh, prepare. Delete that. And now, no, undo that. Undo this. Undo that. That is not in the correct. What have we done? This is in millimeter gram seconds, so something is off. It's probably said, hey, you've made something that's too small. No, let's delete this. Delete this. Did I save something wrong on this screen? This goes back to... Oh. Hey, Lucid, how's it going? I finally have... Just kind of hanging out. Hanging out on stream. Good to see you. Yeah, so let's just kind of be looking at what did we do here when we saved this that made it is it STL? No, see, should be options should be in the correct range. I think my Bamboo Bamboo Labs just didn't like the way it was imported. Sometimes when you do like a small object, it's like, oh, we assumed you put that on the wrong thing. See, that's just so weird. Volume. Yeah, that's That makes it worse. What? Anyway, well, we might have to work with that in a second. Oh. Alright, we're restarting this. It seems to have lost its mind. I wonder if that's because I changed that setting in the middle of it. If it does it one more time, then we'll just move on to the next thing. Yep, we're moving on. That's so weird. Let's see if I do it this way, if it does the same thing. Yeah, it does. Get all this crap off of here. Is that how big it is in Solidworks? Hold up. Have we totally messed this up? Yes, we have. Oh, how is that? Radius is 19 millimeters. Oh, the radius is 19 millimeters. Am I really that? I'm really that dumb. That's what this is. Come on, come on. Yes, absolutely. So Lucid, absolutely going to do kinematics programming. That's kind of the whole point of being able to do this, because it's like, if you don't have something to kind of play with and go through it, then there's no way that you can really learn how to do the kinematic stuff. And so it's like, that's the whole kind of like idea behind just kind of, sorry, my camera is off. The whole idea behind actually getting this is because I've set up kinematic stuff and I've played around with like the demo. There's like a little 2-axis XY picker thing that Siemens has a demo for, but there isn't a way to really have that long enough to like play around, like creating your own paths and things. So that's why I'm gonna go ahead and make this, and so we can have something to play around with, because there's a lot about the kinematic objects that are kind of like how do you make your paths? Yeah, you have your like different steps and different functions, just like you would on like a robot. So like a KUKA or a FANUC or ABB, like these robots have different programs, and so you'll do like a circular path and then have parameters, and then it'll do the thing. And you have all of this in the kinematic stuff. What does that say? A sorting. Yeah, I guess I could. So if you're watching this on demand, Lucid's in chat, and he's asking if we do kind of a sorting program. I've got a little project that I'm doing out in kind of like on the farm, and I'm planning on maybe doing this like an actual egg sorting type of application. And if that is the case, then if I can do that, then yeah, if I do that, then I will yeah, I might do a delta picker to actually like pack off of the belt that we're using, to take and grab an egg and put it over and put it in and do an automatic sorting. That's what I would love to be able to do. So that's kind of the goal. I don't know if this would be able to I don't know if this would be able to kind of like actually be robust enough in the plastic form. And like, I'm kind of like, don't really know how much weight that these little motors combined can put out. I mean, they could put out like, I think it's like 2 newton meters of torque, 2.4 newton meters of torque. But I'm not familiar really enough with these delta picker kind of like the equations for them to be able to like really know how much torque it's going to be required. You know, like I figure this little arm, you're kind of at a mechanical, like this one's only 150 millimeters. So that newton meter of torque. So yeah, a meter, this is only what, 0.15. So you can multiply that by almost like, what is that, 5? So you would be able to get almost like 10 newtons of force at this point. But then the other arm has mechanical advantage on it too. So like I'm not sure how much I would actually be able to pick up with these little motors. I'd love to be able to do an egg sorter. That If not, then probably just get something to play around with. Let's see. I guess we're just gonna have to go back and redo this thing because this did not work. So we want this. And so I kind of want to measure. So, well, let me do this and say from... Hold on, I'm in a circle. So I want... to... Oh, I guess I can't set that. Anyway, so again, these like little things, like why will this not work in a 3-point arc? Maybe if I actually did a 3-point arc. No, it's got to be a center point arc. So 1, 2, 3. So that's a tangent. Yeah. So parameter is the center, first point, second point. Center. Oh, so they're just way too far out there because I drew my circle wrong. Because I was dumb before. Let's just make this for construction so it can stay there. And then let's take this and select this and let's make them coincident. Please undo this. Make this first. We have to fix it in order to force all of this to move. Are you gonna do it? Yes, you're gonna do it. Okay, we're just forcing everything into this. Okay, so we've got. So that looks a lot better. And then so now, let's just take that. No. Go back in and edit. Nope, we're good. So now I want to do this center point arc. And then do this around. Why you no work? Alright, so it's saying that it is... That should be fully defined. It's not. Okay, what's wrong with the sketch? Oh. Gaps. Wonder why it won't let me just pick that. Can't be tangent equal curve length. No. I don't know why it won't let me pick those points. Yeah. So how things going at the plant, Lucid? Just wonderful. I'm sure that there's somewhere in time there's going to be some SolidWorks people that come in and are like absolutely yelling at me because of something that I'm doing that's like super simple. But that's the fun thing about figuring stuff out. Sometimes the best lessons are learned in a difficult way. So maybe it's the fact that this line is not actually equal to this line anymore. I noticed that, right? It should be same distance away from the center line. That should be all good. But it's not defining anything. Huh. And I'm just trying to make a key on a shaft. Why? Yeah. And it's broken. Because, I mean, it's got an open path, so how would it not be broken? Yeah, they are equal. Okay. So now I want to try my center part arc again. That's... maybe it's one... no, it's not. It's center... one. How is that? Anyway, I can just define it. Why is it messed up? That doesn't look messed up. Yeah, it's open. Whatever. Maybe these definitions are messing it up in some way. What? Maybe if I actually go into this, I just feel like I'm over-defined somehow. Yeah, so it was driving that in some way. So let's measure this and make sure. I guess that's gonna be okay. Who knows? But yeah, nice fun little time just hanging out, and that is why that is why my stinking this whole thing is like totally jacked up. So this needs to be 25 in radius. But how about let's have something that's like more moderate. Alright, so now this is what I want to 3D print. This shouldn't take that long. First of all, let's save this. Save as new. STL. Yeah. And hopefully hey, look at that. It's so much better. Oh, which way? Why? Oh, no, dummy. That's a circle. That's not gonna do anything. 90. There. Okay, and then let's just move this over here where there's a little bit of glue. Slice the plate. And then I'm gonna print this. And do I have a different color? Is that PLA? Yeah, I'll do the white. So you can see it. And I can mark on it. Yeah, this should be pretty cool. I may have to... Does it have glue on it? Alright. Let's see. Let's see if my... Before it gets too far off. Let me go back here real quick. Sorry about your ears. Alright, I am back. So let me get bottom right down here. And let's go back and we'll check on that here in a second. But now we can kind of start looking at... I wanted to kind of draw... Do we want to draw on the same plane? Or do we want to draw on the face? Let's draw on this face. Kind of like our spline pattern. And let's just kind of double check. What was the radius of this guy? Let's measure this. 50 millimeters. Sanity check. Again, a lot of engineering is just like when you're going through and like, does that even make sense? And it's like getting it into a ballpark to where you can kind of like just say, yeah, that's way too, well, yeah, that's way too big. Because I mean, this is going to be like the outside of our, and what really looks better spline wise I'm just going through and I have this motor here, and obviously you could be, oh, we could check on the 3D modeling as well. But I'm looking at it and like it's probably 35 millimeters across. Let's do this. Let's do this. Let's bring in, go back to, where's my, yeah, these are completed. Let's download these. Let's go to that folder and extract. Now come over to assembly. That's fine. Let's just kill all these, pretty much everything. All these mates are gonna have to be redone anyway. So, oh, look at that. when nothing is like mated together, everything seems fine. Just get stuff out of the way. Um, so what we want to do now, I'm just going to take and got this folder here, put this, and we're just going to bring this model. Ooh, fancy. So that actually made the part. Dang, that is a cool model. Much better than I could ever do. But, so, what are these faces? Oh, it's some sort of weird thing. I bet you it's... Okay. So this is the part itself, and so this is the... Oh, it imported it and made a solid part. That's pretty cool. Let's get over here and into my Delta picker and put that in there. And which, by the way, the X1 Bamboo Labs X1 Carbon, it's going through and leveling the bed. I didn't show this yesterday, but yeah, should be pretty cool. And so again, I talked about the Bamboo Carbon. It's definitely not the least expensive, but I have experience with 3D printing. I started out on like a handmade one, 3D printer, and so I knew that I didn't want to be spending my time messing with a 3D printer. And so bought that thing, and out of the box it pretty much started printing. You have to understand, like, tweak the bed temperatures and kind of printing temperatures and nozzle stuff, but other than that, yeah, it's definitely worth the extra money, put it that way. No, this is a second instance of that. So let's go back to our model now, not our model, our assembly. And now we can go in and say insert components, because we have this 1FL6 motor, we can bring this in. And so what I want to do is, can I actually remove that out of that model? I don't think I can, but I can, because this has a key in it. I'm going to bring in my spline converter shaft, bring it in here, and I want to take and do a mate. This with this, that's fine. That's fine there. Now what I want to do is, can I rotate? Did not like that. Why is it not working? I should be able to rotate that. I don't think that mate is the correct type of mate. No, it should be concentric. I should be able to, like, rotate this. Anyway, what I was going to do is I was just going to check and look for like an interference. I mean, obviously that looks like that's going to work, but I was going to try and rotate that around. I don't like that. Let's do this first. Let's say this, go to mates, mates, this line, and this line. And then now I should be able to... Oh, that's terrible. Okay. Okay. Why is that mate having such problems? I don't know, maybe I'm just experiencing some things that everybody knows about SolidWorks and how it's the weirdness of SolidWorks. I don't know. But I do know that there could be another orientation of that mate. Like, oh, I'll show you this. Woohoo! Printing this up. So, it's going through, I think it's got its first little pages down. Anyway, 3D printing away. Go through and test out that part here in a second. If you don't have a 3D printer, this part will literally take, it's going to take 20 minutes to print. So almost, it'd probably take me 20 minutes to figure out this mate on this thing. So we're gonna delete this, but we now have our we have this, so we can go through, and I will do this mate though. This with that. Okay, that looks good. And okay. So what we'll do now is we'll mate this with this parallel. That's good. And then we'll do this face with this face. And we're good there. And now we can take a look and see. I mean, it looks like there might be interferences, but anyway. So there's like some, what is it, evaluate and then interference detection. And then selected components. Delta assembly, yeah, okay. I'm sure. Okay. So it's saying that it's too tight, which probably correct, but it's built into the kind of settings. So it does say that that's too tight there. So we'll probably open that up a little bit, but it's good to know. All right, so we've got that. We've kind of got things at least looking like they're coming together. But now we kind of start looking and saying, okay, I think we want to support this out a little bit further. And so we kind of like design in situ. So, because we really want to extend this out to kind of like, so let's go normal to that, right? We really want to extend this all the way out to where it's at least supporting this end out here. So let's go in here and say, I think we can actually edit. I want to say edit the sketch of this. So we are now editing this sketch in the actual assembly. And so it is doing this work. Let's just kind of make this come out to here. And then we can, undo that zoom. That was terrible. That was a bad idea. Oh, it's getting worse. Well, let's just continue on down little ways. We'll do this. And then now I need to reset my view. Come on. I think I actually... Nope. I've completely messed it up. But see, this is where like this line I wanted to extend out. So just for right now, let's select these two here and make them for construction so that this will build. And now we can go normal to it. Kind of get back to where this was. And I kind of want to just extend. I know this sounds insane, but can I do this on this, edit the sketch? Nope, didn't work. But I guess I can go back into it. I'm just trying to make this to where I can we're just gonna call these infinite length just so that I don't run into this anymore. And then now, I guess I really needed this one to be extended, not the other one. So, what's the best way to do that? Edit sketch. We're just going to extend this out. No way is this. Oh, this is in. No? How is that a length of 0.12? Whatever. I guess my assembly is in meters. Because that's like 121. Got Lucid is in here. But I want to just like extend this out like this. Like that. Did that extend all of them out? It looks like it did. But how? Whatever. Don't ask questions. So now I actually want to edit this sketch. And so now I can take this point and this point and make it coincident like that. And I can undo the fact that this is for construction. Same with this guy in here. What's it gonna break? Everything. But yeah, so now we have. Okay, that's actually pretty cool. So we can actually, well, why does this sound? Oh. It's like it got quiet a second ago. So if you've ever been in a room with a running 3D printer, you know it like sings the songs. It sings all sorts of like melodic music. Yeah, Lucid, I appreciate you hanging out. It makes it to where I'm technically not talking to myself. But here in a few minutes, I'm going to be talking and I'm going to look over and it's like 0 concurrent viewers. And I'm going to be like, okay, I'm talking to myself. But that'd be normal. Yeah, so the 3D printer, it got like quiet. Because like when it's doing those fast motions like that, it's making like very specific sounds. But anyway, so let's keep plugging along on this. because now we're sitting here, we kind of like, I'm looking at this and I'm realizing, I'm like, all right, we've got some possible issues, because I'm looking at this and I'm like, if I want to come out, I'm gonna have this overhang. So I want to come out and like support, because I have to support this kind of structure here. So I have to make a structure that comes out here in order to support this thing. So I have to extend this out. And so I have to sit here and like, what is driving this distance? And I'm sitting here looking at it and I'm like, okay, well, it looks like it is just a simple fact that like this distance here is too wide. And so that's digging into this. So like if I rotate this around, if I want to move this edge back this way, I need to move this edge back. So yeah. So what do we do? How do we do about that? Or I can just say that's all the edge I'm gonna get, and then just kind of build it up like this. I think that's what I'm gonna do. And I'm just gonna build this all the way up to this edge. I think that's the best way to do it. So now we want to look at this extrusion. So let's go normal to this. And I want to, so that's this extrude. So I want to modify this sketch. However, yeah, I think I heard my print complete. Yeah, it's cleaning off the tip. So I'll try this out here in a second. So I actually can change this line now, because but in order to do that, I'm gonna have to delete this driving feature. Okay, because I'm gonna delete this and this. Oh, it doesn't like that. Let's not do that then. I don't need to delete it. I can say that point and this edge are coincident. Bam. That point and this edge are coincident. And then I can draw point to point. And that should make that extrusion okay. Yep. So now that gives us the ability to put a little bit of material on this edge. And what I'll do on this other side is I will just move this whole edge out a little bit. So, because I want to kind of like just create this like a flat thing here. And so what I'm going to do, I'm going to go back normal to this. And I'm just going to pick a spot. This boss extrude, so we want to extrude all this at one time. And so we're going to edit this sketch again, go back in, and I'm going to undo literally what I just did. Not everything though. I'm going to take this point, delete this, and I'm going to just drag this there. And then I'm going to evaluate and just measure from here. That is not what I want. Okay, never mind. I'm not going to do that. I'm gonna say that's close enough. So that's close enough there. And so now what I want to do is take and make a line and just extend this out. We'll do something like that. And then what I want to do now, did it really go through all of that music? Got quiet all the time. Like that's that's crazy. It's all 139 funky dance and electronic music. So we'll start back over here. Alright, so now, can anybody tell me what this music is from? Oh, it's so funny. So funny. The internationally viral hit, Only Up. Actually, it was from YouTube, and then they used the video or the music in their game because it's all copyright. Oh. What do we have that disappeared? What is this? What am I in? Oh, this is the face. Okay. That's fine. As long as it's... That does not look right. I think it broke it. Did it break it? Nope, I don't think so. Alright. So now we have a little thing here that we can work with. Because again, once we create this body, we'll go back into the part and then we'll roll forward that circle and it'll make 3 of them. So that's pretty strong, but it's ugly. And so we don't want ugly. We want to sketch on that plane. Get this, like, hide this. Get it out of my eyes. Go. Okay. Yeah. Go away. Ba-da-ba-ba. 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 I want to sketch on this plane. No, I actually want it to be in the part. Well, I guess, yeah. Alright, so what I'll do is I'll go to the actual part here. And then I'll do it here. And the reason you actually want it in the part, because if I were to do that context of the assembly, then it would, when I do that rotation thing here, it wouldn't actually be on the other sides because it doesn't know about it in the part. So we're gonna do this, and so let's go normal to, let's do a sketch. And let's make a fancy truss looking thing. And again, when you're doing any sort of like drawings that you want to do a feature of, then you want to make sure that you have a closed contour. And so always just be kind of thinking about everything and making a closed contour. So we define our outside area, and then I want triangles. Where do we want our triangles? Do we want a big triangle here? Triangle here. No, we won't. How do we want our triangles to look? Because, I mean, that's nice. But if we're going to be... Well, I say that. I'm not going to put... Because I'm going to 3D print this. We're not going to get too fancy. So we're just going to say, okay. And then now we're going to do a cut from that. So we're going to select that. Features. Cut. And then we're going to say flip side to cut. And that is not what we want to do. So we really just want to get rid of all of this out here. So let's do this then. Let's edit this sketch. Instead of making it like this, let's actually get rid of these things. So, which it will not like this for right now, but we're going to go through and make this for construction, just so it can be defined. We don't need that. We do need this for construction. And we'll call this for construction. And then we go and do this cut. And now we're going to say not blind. We're going to go up to next. It's going to whack that off. And then let's just see, let's roll this back right now, see what it looks like in our assembly now. So now we're going to go down and look at our assembly. Yeah, rebuild it. See? It looks pretty good. And that looks like we would kind of want it to, but we have a problem. How in the world are we going to access anything on this side? So, I guess what we need... I'm looking at this. We're going to need... Because you want to have it supported on the side. I mean, I guess... Do we even need that side? Because my original thought was to support everything. But if we have this, like, splined shaft thing... we could pretty much do our thing with this. Triangles with 3 sides. Yeah. Sorry, there's like a delay in the thing, and so your jokes, Lucid, are delayed. We've got our got an issue here, because I mean everything is wonderful until you actually have to build something. But yeah, so let me go over here and grab this part off of the Bamboo Labs. Let's do this, and then let me go grab it real quick. I'm gonna mute this time, so when I accidentally bump the microphone when I'm sitting back down, I don't kill your eardrums. So, I don't know if y'all saw that, but it kind of another cool feature of the Bamboo Labs has got these the plates here are actually removable. So I have, well, I guess we could do this. So I have the actual plate here that has our part. So as we're kind of going through and doing this, pull this thing off, and like once you start getting like buildup like this on your plate, you definitely want to clean it. But you kind of can go around and put stuff all over it. Because if you, I mean, really the glue is just right there, but the more and more, it's really actually very difficult to get PLA off of these. So, moment of truth. Does it look straight? It does not look straight, does it? It's definitely not straight. And just as I feared, it is too tight. Like, there's no way that this is going on. But the tolerance on the keyway is good. So maybe it will go on. Maybe I just have to not be terrible. It's just too tight. Actually, no. No. Not. I would love to not destroy my desk hitting this. I don't know about you guys. Actually, y'all would probably love to see my desk get destroyed. All for the memes, right? Well, let's see. And I don't think my leg is going to be strong enough to. What did this actually turn out to be? Yeah, 18.8 is what it actually turned out to be. So, well, I guess, yeah, 18.8. Yeah, for those that have experience in 3D printing, I guess it's 18.9, but like, still, just that little bit is just doesn't work. Yeah, it's 18.9, 18.8 millimeters, and just I could probably take and get this on, but if this were high speed, that probably would be what we would want to do. But you know, I just don't think it's gonna work. So we learned, and so that means we probably want to up it. So if that's 18.8, let's go back to that part. Actually, let's go back to this part. What is it? Line this. And so let's go back into the sketch. Edit the sketch. And of course, this is the... So 9.5 turned out to be... So we want... That's probably going to be too big. And then we need to make sure that when we measure our tooth, 6, 3, 3. Hopefully that works. Hopefully it didn't skew it at all. I don't like that because it doesn't seem to have updated. Oh, because that's driving a... I see. So we're gonna have to completely redo it. in order to get that. So what we have to do is we have to change the diameter of this to 9.6. Why is it doing that? This is so strange. Like, oh, maybe if I'm 9.6. Maybe if I actually did it. Hold up. Maybe then if we do this, because that was anchored. 9.6. Yeah. It did, but then... Okay, that's good. That looks fine. I forgot I had that anchored. So... We learned. And so, the reason I printed this out in white was so that I have a this mark on it. No. So I could kind of mark up like the idea of what we'd be wanting to do. So this is kind of the idea of what I'm wanting to do. Gosh, that light is bright. You can't even like see it, it's so bright. Put a shadow on it, there we go. So kind of around those edges, wanting to put these kind of splines. So let's see how this measured out now. Let's measure this. Because sometimes when it does this, it'll change weird things if you don't have things. Yeah, okay. So that looks good. All right. Okay. So what I want to do is the top plane for this. I want to do a sketch that's kind of like a dimensioning sketch. That's just like a center line. And we'll do this like this. And I really just wanted that sketch there for... No, go above that. Move. Whatever. Oh, it got associated with something. I'm wanting this as like the base like drawing reference sketch, but apparently it got associated with something that it shouldn't have. Because I want this above everything. There we go. Because what I'm wanting to do is now I'm wanting to do a feature. I'm wanting to draw this face. Okay. Oh. Now I wanted to sketch on the face. And I want to draw out kind of like this wavy thing. Like a sine wave looking thing. And then I want to revolve that however many times. But now I'm thinking about it, I would need to do math. And I don't like math. I just want to like draw something and then like copy it. But then I want it to be the correct shape. do the what's the circumference? Because how do I make this right? So I want to do a revolved feature that goes around and does all of this stuff. And again, we're figuring stuff out. It's also not a lot of people on. We're just kind of hanging out. Huh. What tools do we have that we can use? First of all, let's get out of this measure. Let's in our sketch. I thought that there was like a I mean, it's definitely the circular sketch pattern. Video to select. What if we just had like 6 evenly done things? And so we just do as many as we can. That's what we'll do. This is like totally random, just like off the wall. Oh, I'm already in this thing. So let's do this. Let's take just like do something like that. And then let's select the midpoint. Then this line. Ugh. Line at sketch. Delete this. Coincident. Well, that's dumb, but whatever. That's all that matters. Just want the midpoint to be there. Don't really care how wide this is. And then I want kind of like so I'm removing this. So we're gonna do like a tooth looking thing. Okay. And then we're gonna go and do like I want to fill it out that way, but I guess what we really just need to do is do a fillet like this. Yeah, of course, we only want like 2 millimeters. Bruh. Okay, whatever. Alright. Gonna do this. Gonna do this. We're gonna do 4 millimeters. Alright. That solves that. Now I can go in and do my little 2 millimeter fillet. Fillet. No, it's 4 millimeters. It's a 2 millimeter radius. That doesn't. Resulting. No, does not. Whatever. I guess it's not going to be 2 millimeter fillet. It will be a 1.9 millimeter fillet. And everybody's happy for some reason. That's not what I want. I want it to go the other way. Let me make it go the other way. Oh, I got you. I know how. Again, here's where Solidworks experts will be like freaking out. We just make like a little feature to go out and down and over and like that. And then now we take and delete this thing that this is going to hate. And then now this. I guess we could just do this. It's 4 millimeters. So that. And then. Wonderful. Whatever. 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 Doesn't that look great? Just looks wonderful. And we say okay. And it's got a bunch of crap. But we don't care. We don't care. And that's a cool sketch. Right. So we want to go all the way through these? Yeah, we'll make it simple. Uh-huh. 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 Mm-hmm. And then now we're gonna go. And then we're gonna do a circular pattern. How many is gonna be right? It's looking pretty good. We made a gear. Alright. I'm probably going to print this out while I go get some dinner. Because we changed all this up now. So, I'm going to save this. And then now, what we need, we're going to need to like copy this like outline. Which is now weird. And then do like an offset entity from that. Okay, so that's probably going to be on another thing. And that'll have to be in an assembly, won't it? Anyway. That's a problem for future us. Yeah, anyway. Looks pretty good. So let's do save as new. Now I'm going to set this up. I'm going to put this back on here. Which, by the way, when this prints out, it prints out like this little, like it calibrates the extrusion. So you get like all these like annoying little things. But it makes it to where, again, all the stuff that like you have to check before a really long print, if it gets through all of that and prints the first layer, you could pretty much bank on the fact that it's going to make it all the way through. So, let's see. All right. I am going to do this. Alright, we're gonna print this out again in white. We're gonna send it over. And oh, alright. We're gonna go back. Go back to this, and we will start. How long have I been on here? 2 hours. I'm probably gonna end up and close off the stream here. Again, it's been just kind of laid back stream today. If these get any sort of traction, I think that they're kind of useful, and you can kind of like go through and look and watch different parts and kind of like the different process. It's really more about kind of documenting the process of designing this Delta picker. And so kind of like when we actually go through and do the streams with the Siemens automation and all of that, it'll be able to reference back into some different things. So I'm going to end the stream right now though. I appreciate all of those that have joined in. I love seeing people just come in to hang out and do all that, and hopefully you'll have a good rest of your evening, and I'm going to check out, and we'll start back the next time. I don't know when it'll be. I've got some stuff I got to do tomorrow, so I probably won't be able to stream tomorrow. But yeah, I'll probably do another stream of like a real automation stream about some of the topics, because I've had some questions that have come up, and kind of talk about general PLC topics again. But yeah, anyway, if you've watched this on demand and it's been helpful to you, as always, hit that like. If you're not subscribed, please consider subscribing to get more of this, but really a lot more of the full general automation. Again, this is just kind of like laid back and streaming and chatting and stuff like that. But anyway, I will catch y'all later, and we will continue this project at another time. I will, yeah, take it easy. I'll see ya.